I guess we should go ahead and jump in. We got people kind of coming in, looking good on that. So yeah, this is our second weekly kind of live update and Q&A for our Wefunder campaign. Got some fun, quick little updates that we'll do in a second. Figure I'll start off basically going over what we do, what we're building, where we're going. We'll kind of go into our background a little bit real fast. We'll get into the updates. We've got some fun questions that like we have just gotten personally ourselves over this week, covering a lot of like business side of stuff, both on near term, long term, kind of all that general plan. So we'll jump into those and then answer questions also coming in through the Q&A. So yeah, quick kind of overview of who we are and what we're doing. So our whole thing is large size 3D printing. So we are using large size 3D printing to help companies that are building larger size machines get the larger size plastic components that they need to make those machines. And the whole reason we're doing this is because being able to quickly and cost effectively produce high strength, large size plastic components locally to our customers, and I'll get into that in a second, is going to be a total game changer for both manufacturing and supply chains. Just kind of real quickly on our team's background, Sabine and I will go in a little bit deeper here in a second, but my background is mechanical engineering. Sabine here, our COO and my co-founder, her background is polymers and material science. And then our CTO, Matt, he is a senior level software engineer. So we have all the nerd bases covered.
You can already tell.
Yes. Oh, yes. If you know the background, then you know. So now, what do I mean by like large size machines? Well, the best way to kind of describe what we do for customers, how we're doing and what we're building, what makes us different is that we printed the entire frame and structure of a nearly 5 foot tall autonomous cleaning robot in 1/4 of the time and for 1/4 of the cost compared to all other quoted options. And the most important thing about this is we did this on our technology demonstrator prototype, which was never intended to actually run print jobs for customers. And the reason for this was because when we originally started out, we had the plan of selling machines to customers. But the more potential customers that we talked to, we realized that doesn't make sense because for the vast majority of those people, they don't want to spend hundreds of thousands of dollars on a machine to then just have to spend lots of time and effort running it in-house. They just want the parts that come out of it. So to meet this demand and need that exists in the market right now, we pivoted to a purely on-demand service-based model where we're using our own machines that we develop and build, using those in-house to print components for our customers, with the long-term vision of building and running an entire nationwide network of local microfactories so that we can then also cut down on the supply chain complexities and just cost of shipping associated with moving lots of large size objects long distance. It also makes things more efficient and also environmentally friendly, which another benefit. We kind of need to focus a bit more on that given how everything's on fire.
Literally.
Yes. And even though there are lots of potential markets for us to tackle, everything going from oil and gas to aerospace, automotive, agriculture, and oddly enough, like in a really fun way, the entertainment industry potentially doing things like props and sets. The industry that we've decided to focus on and go after first is printing parts and components for autonomous mobile robots, like the cleaning robot I mentioned earlier. After talking with lots of companies in this space, we realized this is the perfect beachhead for us to go after because their use cases are perfect for us. Lots of large size, high strength plastic components they use to build their machines. And they're also much more open to new ways of doing manufacturing, especially compared to your more legacy industries like the automotive and aerospace, which are much slower to adopt new technologies and require a lot more validation, which we're definitely doing going down that road. That just takes time. So that's just kind of a quick overview of what we're building, the kind of vision of where we're going. Figure Sabine and I will go into our kind of backgrounds really fast. So like I said, I have a degree in mechanical engineering. I also invented our core technology of this new 3D printer design that we're building this entire production and fabrication system around. The patent is fully issued, and it was issued on Star Wars Day. I'm never going to not find that to be both awesome and funny, especially since on the wall behind this camera there is a lot of Star Wars stuff on the wall. So that was a really fun little cherry on top of a long process.
We should make it into a company holiday.
Oh yes, done. That's going to be, that is May the 4th is always going to be a company holiday now.
Brilliant idea.
Yeah. Well, speaking of which, you want to go through your kind of background real fast? Yeah.
So yeah, I am, my name is Sabine Reswagli. I'm the CEO. A bit of a unconventional background, going from, well, not so unconventional, but going from physics and fine arts into material science. I went back to Argentina in order to try and complete my degree. I was a little shy of completing it, but I wanted to kind of escape the what you see here, like the sanctum sanctorum, and actually like use my knowledge and apply it for the good of humankind. No, but I've worked pretty much my entirety between biochemistry, physics, as well as material science labs, and I thought it was a good time to kind of apply my knowledge somewhere where I thought I would be really useful, i.e. 3D printing.
It is kind of a perfect fit.
It really is.
Of all that capability. And like I said, our CTO, his background is all like badass software development. Even was the technical lead on building out Hewlett Packard's custom PC, like online building portal or program. This is why I'm a mechanical engineer.
No, and he's and the great thing about Matt is he's like, what I love about him, he's extremely fast to catch on. So like the few initial days that we met, like he had no knowledge of 3D printing. And it was like, then we went for tacos, and apparently tacos was the impetus of like, oh, hey, I understand everything about 3D printing, just for everybody out there.
Yeah, and then started like being like, oh, this is how we should map out like the back end architecture and start like getting that all put together.
Yeah.
Yes, he is very, very awesome software developer. Cool. So that kind of goes through a bit of what we're building, who we are. Figure we'll kind of jump into some of the questions that we've both gotten online and that just kind of gotten a lot in person. I was thinking today would be more of kind of a business side focus, both kind of near term and short term. So one of the questions that keep getting, which is totally understandable for doing Wefunder raise, is what are we raising this money for, and what are we going to be doing with it? Really, the biggest thing about it is getting out of the garage, because right now we have basically built all of this, all like the technology demonstrator prototype, all of the stuff to build the next generation machine. It's all in my garage right now. And it's time for us to, if we're going to take this to the next level and actually be able to build everything and start turning this into a 3D printing empire, it's time to get out of the garage and get our pilot facility set up. This will also let us kind of finish fleshing out our initial team, finish the last little bits of hardware development on our next generation machines, and then build out that first set of service ready 3D printers so that we can start cranking out parts for customers. And then it's just kind of off to the races. Yeah. Sabine, do you have any kind of other things?
With regards to like business strategy and like long term? I mean, no, I think that you pretty much covered it. I think that always the crux of the issue has always been like, okay, well, we have all of these components, we have everything in the garage, but like, honestly, where do we go from here? Like the suggestion has always been beg, borrow, and steal from friends and like steal their garage. It's like, well, we totally would. We have no issue, right, Riley? You and I have no issue doing that. The problem is therefore like power. Like it simply is. And it's going from one scenario where it's kind of like a jump horizontally rather than a step up. And we also don't have the capacity to monitor from different locations. Like it would be a time suck, especially since Austin, thank you, Californians, have kind of the infrastructure, it just takes too long to get from point A to point B right now. So we would rather spend that time one location, getting work done, and just kind of like Riley said, just grinding.
Yeah. And that also really kind of leads into the one of the other questions that we've gotten a decent amount pretty recently is what would kind of next steps, like a future raise, look, and what would that be used for? And so the way that in startups usually raise stuff, like this is kind of our seed round, then we probably do an A round. At that point, we'll hopefully have like our first 2 facilities up and running, a decent number of machines generating solid amount of revenue. And at that point, it's all about scaling up. And that money that we'll be raising in the next round, ideally won't be going to like buying more machines or anything like that. There are other like debt-based routes to do that are more common for like purchasing industrial hardware that we'd like to use, so we're not having to burn equity. Really, we want that money for expanding sales, expanding like our team involved in that. And then it'll also be for expanding on like the software development side of all of the stuff that we have planned for back-end systems, 3D scanning, machine learning, robotic automation, all of those things, so that we can use like non-dilutive funds to actually expand the hardware of the business, and then use investment from investors to make all of that hardware more and more and more efficient, so that we just get faster and better and higher quality as we go and start expanding out into a bunch of different microfactories all spread across the US. And then that kind of leads into the third big question that had multiple times this week, which I think is a really fun question we probably haven't talked too much about, is what is our exit strategy? Like, what are we building this whole thing for? And really where we see this kind of going the best is a solid, like likely, hopefully, fingers crossed, 9-figure exit in 4 to 5 years. That's like the way that we're setting up this company and how the 3D printing industry is kind of going. We think we'll be like prime for getting acquired by one of these other larger companies, whether it be Proto Labs, Fast Radius, or even like something like Stratasys, wanting to add our capabilities to theirs. Since we are going after a very like specific, massively underserved niche, we're doing it in a very unique and I think very defensible way, so that we can kind of carve out a solid chunk of this industry and plant that flag and claim it as our own. And then anyone else who wants to add that capability to theirs, then it'll probably be through an acquisition setup. We also won't, the nice thing is we're not really competing with anyone else who would be likely buying us. So it's less of an acquisition to get rid of a competitor, is more so an acquisition to add to their capabilities, which makes it much more collaborative as opposed to antagonistic. And I think that'll be a lot better outcome for everyone involved. You look like you were going to jump in.
Yeah, no, I mean, for the most part, I think that's one thing that you and I have always talked about also, is that 3D printing has been so siloed out as well, in terms of, getting 3D printing kind of to the next height. And there's still so many people that don't know what 3D printing is. And I think having getting people to kind of work together a little bit more and merge companies and, again, not be so siloed out would really be beneficial.
Yeah, definitely. Yeah. And also one of the things that I was just thinking through this morning after having a conversation on this last night is the way that we're planning to structure and organize our company, of everything being fully interconnected and running off of a common back end, even though we're going to be having dozens of these facilities across the United States, is it'll make it very easy for us to integrate into somebody else's system, because it's just a single point of integration, as opposed to if we had set up like a franchise model, which some people have suggested. That means that they would have to basically like integrate with each standalone facility, which makes things a lot more complicated and difficult, as opposed to literally just plugging in to our backend system, and then our entire like networking capabilities would almost instantly become somebody else's capabilities, which makes that whole transfer very, very easy. to do. Let's see. Let's answer some questions. Had one fun one that I guess can kind of go into a little bit. I'll probably do an actual video on it, but asking to kind of talk a bit more on like the actual technology and what makes it different. Quick overview, because they were asking if it's a Core XY or what kind of thing it is. That a lot of probably nerdy 3D printing people out there wanting to know more about it. It isn't any of those. It's a completely different, more or less completely different way of doing the 3D printing process. And what it all kind of comes down to is that we have two gantries, which are the structures that move around kind of in the X and Y, working together and splitting up the process. So there's a bottom one and a top one. The bottom one actually has the heated nozzle or whatever is depositing the material, and then the top one carries all the heavy stuff. Right now, they're driven by ball screws. In the next generation machines, the lower one will be driven by really badass linear servo motors, and the top one will be a simple belt drive system to make it very cost effective and still have decent capabilities, because the top gantry doesn't need to be particularly accurate. Its whole thing is the bottom one actually runs the tool path, and the top one just kind of hovers above it, and there's flexible connections between the two. And that division of labor allows us to scale up in size very easily and cost effectively. It also allows us to go like very fast, very high acceleration, all of these really awesome things that make the process quicker and work better. But we're able to do it in a machine that's much cheaper and more cost effective to build than if you did it kind of a brute force way. Let's see. Sabine, have you gotten any questions recently that
from people? Not as of like the past week. I think that I always primarily just get you know, if you're building out 3D printers, kind of based on the last question that you had, if you're building out 3D printers, how can you really keep quality? Aren't you kind of stumbling upon the same issue that, for example, like 3D hubs have? Even though you have printers in-house, you know, you can't monitor everything from everywhere, you know.
And that one's a really easy one to answer, because our answer is yes, we can and we will, because that's our entire plan, is to have everything be fully monitored. That's one of the things that I think a lot of people have a bit of a misconception about, is that each one of these machines will be its own standalone machine that's like being run and being fully taken care of, and all the decisions made by local people. All these machines, every single one we're going to build, is just going to be like a node on a network, and it's going to be almost entirely controlled by the backend system, while getting full feedback of what's going on with that machine. So which parts are going to be printed on which build plate at which time, and like the arrangement and all that stuff, that's all going to be determined by our backend system, or like the people, I just realized I'm framed a little low, at kind of our headquarters, which will be here in Austin. And because we're going to have everything connected, like true like Internet of Things, we can also be monitoring all the aspects of those machines, like down to the like temperature and torque of every single motor, so that we know full feedback on what's happening with every aspect of the machine. Not just like, does it have filament, but is there about to be a filament jam, and does the machine need to slow down a little bit? Or is it looking like one of our linear rails is starting to stick a little bit and might need some maintenance? So being able to keep track of all that information and have access to all of it will give us a huge benefit on maintaining quality, ensuring quality control. We can also use a lot of that information and feed it into automated systems to help improve quality as we go along, to where the system can figure out the best ways that, say, each printer should be sliced and run in each location. And especially if we're optimizing machines to focus more on a material, like this machine in this location will be the CF nylon machine, or this one will be for ABS and ASA. And that means we can really get them dialed in to handle those materials really, really well.
Yeah, Yeah,
and
which
then
most
have,
people don't have the capacity for at all, especially since like a company gets not to slight 3D hubs, because they have their, their space in the industry. But having, for example, could you imagine Riley having a 3D hubs version of large scale, like large format? It would be a disaster. Like
yeah,
it would point blank be a disaster, especially, I don't think, number one, if everybody had small scale machine and then trying to MacGyver everything together, number one, horrible. And then number two, having like the off chance somebody could purchase a $500,000 machine. Could you imagine the stress of having that, number one, in your house, but number two, always waiting for somebody to come and service that machine, so that it's kind of like an Apple warranty, right? You don't want to open the 3D printer and start tinkering yourself, because then obviously you're booked. But I think that's another reason why, kind of leading into why larger companies also don't have large format machines, or that some of them do because they love having that in-house and they can show off to investors and yada, yada, yada. But a lot of the times, even if they do have large format, like when we were with Stanley Black & Decker for a while, they did tell us that more than half the time, they did offload a lot of their 3D printing to like local 3D print shops, even though they had a very substantial 3D printing network in their company, I guess in Maryland. But they still preferred to offload that work to somebody else, because, I think that they were just extremely busy and didn't have the time.
yeah, and I think that also goes into like that if you go on to say hubs or Xometry or a bunch of the other service providers that are out there right now, and you try and do something that's over, say, 500 millimeters in an axis, it starts getting very expensive very quickly, or it has to be like a custom quote system or a custom quote setup, which means that they're probably going to use smaller machines, break it up, and then try and glue it together, which just makes it so much more difficult. And a lot of this just because there aren't that many larger size machines out there, which is why we're kind of really focusing on that and doing it in a much more cost effective and I think just all around better way.
Yeah.
That will bring all these new possibilities that really just don't exist in a good way right now. Like you can do some larger size stuff, but it's usually either cost a lot, takes forever. Most of the time it's both. And quite often you end up with an inferior product because they had to split it up into smaller pieces and glue it all together.
Yeah. Can you imagine trying to do functional testing with something where it's like hacked together and like, obviously those points of contact are going to be a lot more fragile.
I mean, that's what we had with that
around.
with the electric aircraft startup we were working with, that they were having to do that. We came in and were able to print some very large parts for them, and they were able to do functional testing. And it kind of really showed how the stuff that they had kind of hacked together that took them weeks to do on smaller machines and lots of man hour, it wasn't as circular as it needed to be, to where it was actually like rubbing against the perfectly circular things that we printed all in one shot, to where they then kind of had to modify and tweak stuff. Yeah, it was fantastic example of how that's just a bad way of doing stuff.
Yeah.
Let's see. So gonna try and keep it a little bit shorter today. Last time we kind of went a little bit. I think 45 minutes is a bit long. So probably gonna try and keep this to the half-hour mark, or maybe a little bit faster, since we're doing these on weekly. It's not a big deal to answer questions next time. So we'll probably stop there on the questions. Sabine, you have anything you want to kind of just throw in? Oh, did I do announcements? Like actually fun updates and stuff like that?
No, you didn't do that. And
yeah.
you also, I don't know if anybody's interested in kind of going into a little bit more deep into the tech.
That I'm probably just going to do another video after this. Like I'll actually go out there with the machine so I can dive in a little bit more on what makes it different. So fun updates. We just hit 150K like last night. So yes, happy. We are at 150. Yeah, currently at 151. We had another like 1700, which it was really funny. Somebody actually invested $777, which I saw that and I was like, all right, I guess they're rolling on it being lucky numbers. But so we're already 3/4 of the way to our minimum. and it's only been 2.5 weeks since our public launch. We're also at 180 investors now. So a whole lot of people have believed in us and think we can actually turn this into a big, huge, amazing thing. So thank you very much to all of those who believed in us. Also, we've got some fun potential customer jobs in the pipeline right now. Some of them actually from people who have invested in us and then reached out being like, hey, I'm working on this cool hardware thing. Can you print it out? So that's what a good chunk of my day today is going to be, actually looking through all the files they sent over and see what that all looks like and whether it fits the capabilities, the current capabilities of our technology demonstrator prototype. Yeah, so it's been a really fun week since the last time we did one of these. We've had a whole lot of progress. We're trending on Wefunder's hardware page, so that's fun. It's like us and 6 other companies that are really kicking butt. And yeah, I think that's kind of it. Do you have any fun updates, Sabine?
Not quite. I've just been in the grind of reaching out to people to say, hey, we're on Wefunder. You want to give more? Oh, you already gave $100? No, it's a fine. You know, just keep going. Come back to us in 3 weeks. Yeah.
Cool. Well, I think that's probably pretty good. We'll hit it there. We're at just about the half-hour mark. Don't want to make these things like too crazy for people to be able to watch later on. 45 minutes is probably a bit much, but when you're talking about fun, cool, nerdy stuff, it's pretty easy to get carried away. So I'll probably stop this here, and thank you very much for joining us. To all those who have invested, thank you very much for believing in what we're building and our big, huge, crazy, awesome vision for what the future of manufacturing here in the US can be. And we will see you next week. Bye.
Bye.